Hello everyone. In this video, we're going to be talking about how we can calculate the discriminant and how that can be used to identify the nature of roots for a quadratic function or a quadratic equation. So the first thing to note with the discriminant is the actual formula that's applied with it. It's b squared minus 4ac, where a, b, and c are the coefficients of a quadratic in standard form. Now, you will recognize this for those of you that are familiar with the quadratic formula. This is the radicand portion, basically the part of it that's underneath the radical. And what we're going to talk about in the following slides is what's the whole purpose of this? We're not actually solving when we calculate the discriminant. That's an important distinction. The discriminant is going to tell us about the answers. It's going to tell us how many answers there are, whether or not they're real or imaginary, whether or not they're rational or irrational. So the whole purpose of the discriminant is not to tell us what the answers are, but to describe the answers. And this can be helpful if we're trying to decide how we should go about solving a particular problem. Now, before we even get into the notes for what the different possibilities are for the discriminant, let's try to break it down ourselves. When we calculate this, and remember A, B, and C are all coming from the coefficients, so those are going to be numbers that we plug in once the quadratic's set up nicely in standard form. What are the different outcomes that could happen? If I calculate this in the most general sense, one thing that can happen is I could get a positive result and get some positive number. I don't actually care what the plus sign looks a little weird there. I don't care what the actual number is, but I can get some positive, right? Um, on the flip side, I could calculate the discriminant and get some negative. And people usually tend to forget about this one. I can calculate the discriminant and get, what's the third option? I could get 0. Okay, so now let's revisit this. I don't know why my signs look so weird. Um, if we get a positive number, what's that going to tell us? Well, we're basically going to get plus some radical and minus some radical, so we're going to have two solutions. Now, we'll talk later on in this video about how you can tell whether they're rational or irrational solutions, but for right now, if you calculate the discriminant and you get a positive, that means you're going to have a positive radical, which means you'll have two answers. On the flip side, in red, what does it mean if we get a negative discriminant? Once again, this doesn't matter if it's -5 or -500, but if we get a negative, what does that tell us? We're going to have a negative under the radical. What's the problem with that? You cannot take the square root of a negative, so we call this imaginary. So there are no real solutions. There are imaginary solutions. We just simply say this is imaginary. And the third and final possibility, this would be, I guess, the rarer of the three. What if we calculate the discriminant and we get 0 exactly? So if we do plus and minus of radical 0, which is basically just 0, is the plus minus really going to have an impact and create two different answers? Let's say my b value is, 5. -5 plus or minus 0. Does that plus or minus all of a sudden really make a difference? No. So this is going to be the case if we get a discriminant of 0, we actually just have one solution. So these are breaking it down and explaining it. Like I said, we're going to jump into the notes where you could just kind of memorize or have these things down. But I think it's helpful to understand where all these different ideas come from with the discriminant. These are the three main possibilities. And we're going to break down that blue positive option a little bit further on the next slide. So these are the notes that we just talked about. If you'd rather have them in a more clear sense here, remember we said if your discriminant is a positive, that is b squared minus 4ac is greater than 0. That's an inequality way of saying, hey, what if it's positive? Then there are two real roots. If it's equal to 0, there is a single root, because remember, all of a sudden the plus minus of radical 0 or plus minus 0 doesn't really have any impact. You're no longer going to have two answers. You're just going to have that one. And if we get a discriminant that's less than 0, that is, that it's negative, it's going to be an imaginary solution, imaginary roots, and that's because we can't take the square root of a negative. In red, you don't have to copy this down, but this is very, very important with the discriminant. A lot of people try to make a connection between what they get for the discriminant and what the solutions are. And we didn't even do an actual problem yet, but when we do one later on, it'll probably make a little bit more sense. Let's say I end up getting 40 for my discriminant. 40 is not going to be involved anywhere in my answer. All I really care about the fact that I got 40 is that it's positive, so that means there's two answers. That's it. You drop it there. There's no connection between what the solution is and what your discriminant was. You're just basically using it to determine, hey, is it positive, 0, or is it negative? That's it. And now let's take a look at the question on the bottom. How can we use the discriminant to tell if the roots are rational or irrational? This all has to do with the fact that we're going to be taking the square root of something. So obviously we want it to be a positive number. But what kind of positive number would work out nicely for us? If we're taking the square root of something, we know the discriminant is going to be underneath that square root. Wouldn't perfect squares be really nice to have there? So if we calculate the discriminant and we get any type of perfect square, we know our radical is basically going to quote unquote disappear. Let's say I get a discriminant of 16. That means in my quad formula calculation, I'm going to have radical 16 in there, which means I'm not going to have a radical much longer because it's going to become 4 pretty quickly, plus or minus 4, right? So I'm going to add a little bit to the first bullet point that we initially had, which is that if it's a positive perfect square, so something like 4, 9, 16, 25, even 1, there'll be two rational roots. If it's anything else, if it's any non-perfect square, they're going to be two irrational roots. By the same logic there. If we're going to have radical 17, let's say, that's a non-perfect square, we know our answer is going to involve a radical, it's going to be irrational. Two rational solutions, roots. We didn't really talk about this, but that second bullet point, when you have one root, that's also going to be one rational root if you want to add to that. It is going to be a nice answer because remember we're taking the square root of 0, which is just 0, so we're not going to have any radical at all. So this will also always be a quote-unquote nice answer. If you do have one solution, it's never just going to be a radical. It's going to be some rational fraction, whole number, something like that. And this is where we really can get into the practice of this. We're going to calculate the discriminant for two examples here. So in the first one, I'm given a function f of x, and we're asked to describe the roots. We're even told, hey, use the discriminant. So I'm going to identify what a, b, and c are. I always think this is a good step. It's a precursor for using quadratic formula. Being able to do that kind of helps you labeling things, kind of gets the ball rolling. Now my discriminant formula I'm going to write down as well, which is b squared minus 4ac. I'm just using capital letters. Obviously, you don't have to. And now I'm going to plug in 8 squared minus 4 parentheses 3, 4. And now you can type this in as a whole shot into your calculator. Some people end up making the unfortunate mistake of doing, let's say, obviously we know 8 squared is 64. They'll do 64 minus 4 and then multiply that by 12 or something. You don't want to make an order of operations mistake, so you can literally type in that whole expression into your calculator. So that's going to be, let's see, 64 minus 12 times 4 is 48. So 64 minus 48 is going to be 16. So remember, 16 has nothing to do with the answer. We're just observing the characteristics of that number. So 16 is positive, which means there are two roots. Furthermore, if we go on the last thing we talked about on the last slide, 16 is a perfect square, which means we'll have two nice answers for this. Not a great math term. We'll have two rational roots, two rational solutions to this. Because it is a positive perfect square. So I don't even know what the roots actually are. All I do know is that they're going to be rational wherever they do occur. And on the bottom, we're going to try the same thing. Note the difference here. This is not a function. We can still apply it to equations. maybe instead of using the word roots, sometimes people will use the word roots to mean the same thing. We can describe the answers to this quadratic, or the solution set, if you will. So what do I have to do first with this one? I don't want to go ahead and start labeling A, B, and C. The first thing that I want to do is get it in standard form. So I'm going to move some things around. I'm going to move everybody to the left-hand side. Okay, now that I'm in standard form, I can identify A, B, and C. And technically here, if you're a little bit on the more observant side, if you do see a GCF, you can throw it away. And there is one here. But let's pretend we didn't notice that. Let's just jump into it like normal. A is 3, B, be careful, is negative 24, and C is 48. Once again, I'm going to plug into my formula, B squared. Remember, whenever you square a negative number, put in parentheses, or just be aware that, hey, it should be positive, minus 4AC. So basically, if you think about it, does the sign of B really impact the discriminant at all? No. B doesn't matter if it's positive or negative because we're going to be squaring it. So B has no impact on the nature of the roots. And let me just do a quick check. 4AC looks good. Okay, now I probably want to use my calculator. 24 squared is going to be 576 minus, see, a lot of people make mistakes with simplifying this little order of operations, so always be careful. My recommendation, it's the simplest one, just type in the entire thing. Sometimes when you try to break it down, I know I'm showing the work, but sometimes when you try to break it down into smaller steps, those people end up making mistakes. Double negatives and stuff, I see it happen very frequently. So I get 576 minus 576. Uh-oh. We get a discriminant of 0. So what does 0 tell us? If you forget, really think about the explanations that we talked about initially in this video. That means we're going to have plus and minus radical 0, which means that's going to go away, which means plus and minus doesn't really have any impact, which means we're not going to have two solutions. We're just simply going to have one. And being that there's no radical, we can further include that it's going to be one rational solution. So I don't know what the answer is. I'm going to abbreviate solution. I don't know what the answer is to this equation. I do know that it will be just one answer, what we call a double root. Let's say I end up factoring this, it would be like x plus 3, x plus 3. So you get quote unquote two answers, but it's really just a repeated answer. So one rational solution for this second equation, and that's because the discriminant was exactly equal to 0. So on this slide, we're going to take a look at finding missing coefficients. So this is going to be a similar process. There's going to be some slight changes. Rather than just plugging numbers in and observing whether the discriminant is positive or negative, we're actually going to be solving for something with these. So number 1 says, find all the values of A such that that quadratic, and notice it doesn't actually have an A value, it just literally says ax squared, has two real roots. So let's first make a note. We know that for it to have two real roots, the discriminant, I'm just going to label it D, has to be positive. Okay, so that means that B squared minus 4AC has to be positive for it to have two real roots. They're not doing any breakdown of rational, irrational here. Just, hey, which value of A will make this have two answers, basically. Now let's plug in what we do know. I do know that B is equal to 3. I don't know A, so I'm going to leave A as A. And I do know C is 5. I'm going to do some math here. I can square this. I can multiply the 4 and 5 together to get 20. And now you start to see something develop. So now I have an inequality that I can solve. I'm going to subtract 9 from both sides. Okay, And now I'm going to get rid of the negative 20 by dividing both sides by negative 20. Negative 9 divided by negative 20 is going to be positive 9 over positive 20, and that doesn't simplify. And last but not least, be careful. Remember to flip your sign. So this answer tells us that, hey, as long as A is anything less than 9/20ths, kind of a random answer, but that's what it ends up being. As long as it's anything less than 9/20ths, you will have two real roots. Sometimes I've seen them even ask, like, give a, based on this inequality, give a possible solution. So choose a nice answer, even if you want to. Something like A being -2 works. That's less than 9/20ths, right? So that's how these problems work. You plug in and you're basically solving an inequality. Things to remember with inequalities: when you do multiply or divide by a negative, do remember to flip the direction of the inequality symbol. And let's try one more. This one we're going to find C, the constant on the end, such that that quadratic has two imaginary roots. So we're going to do the exact same thing. We can make a note. Hey, what does it mean to be imaginary? That means the discriminant is less than 0. So we're going to set up this inequality. Same thing as the one above, but now I'm looking for imaginary. The only option we're not doing here is the one root, so that one it would be equal to 0. We're doing the two other options though. I'm going to plug in what I know so far, which is that B is -6. Use parentheses when you square a negative. A I know is 2, and C I do not know. When you don't know the variable, just leave it as that variable. Do my math here: 36 minus 8C. Move the 36 over. Divide by -8. Negative divided by negative is going to become positive. I'm going to flip my sign because I divided by a negative, so instead of less than, it's now greater than. Oops, I forgot my negative sign. That's going to be positive 36 over 8. 36 and 8 have a GCF of 4. If you divide both by 4, we can say 9 over 2, whereas a decimal, 4.5. So if C is anything greater than 4.5, which is 9/2 as an improper fraction, this will have two imaginary roots. So a sample answer, if we are asked that in a follow-up, C being 5 would be the smallest integer where that happens. And that pretty much concludes this lesson on using the discriminant to describe the nature of the roots. This lesson is kind of a precursor for the quadratic formula. Obviously, the discriminant is a component of that, so it's good practice to kind of get us used to using the quadratic formula in tomorrow's lesson. Hopefully, this video was nice and clear for you guys. If you do have any follow-up questions, comments, or concerns, please let me know, and I'll do my best to help out. As always, have a great, safe day. Take care.